Hey guys, I'm going to be talking about intelligence, artificial intelligence, and machine learning coupled with deep learning in this particular series. So, if you've not gotten more insights about how to navigate around AI or deep learning, then you can actually look back to some of my previous courses where I've talked about the potentials of artificial intelligence in public health and in other settings. But for the sake of this course, everything is going to be simple. I'm going to build from theory down to practical. So essentially, basically, in this course, we're going to be talking about the theories that you need to understand about AI, how some of the machine learning frameworks and also the deep learning frameworks like TensorFlow, Keras, and PyTorch. Then at some point in this course, we're going to be having some kind of mathematical briefing. We'll show you how to use apply mathematics and machine learning, and also we'll also introduce some of what a programming language known as Python, so showing you how to navigate around some of the Python frameworks that are responsible for machine learning. So we just want to just build from the basics down to professional level. So stay in touch, relax, and enjoy. Now I'm going to start by talking about what is intelligence. Then we'll look at artificial intelligence, some of the pillars of artificial intelligence, and we'll look at the brief history of AI and slightly why it's rising now, types of artificial intelligence, AI, machine learning, some kind of comparisons between them and with deep learning as well. Then we'll explain some terminologies. We'll look at supervised, unsupervised learning, reinforcement learning, and I'm just going to have a kind of snapshot explanation of what deep learning means, deep learning in image recognition, AI in healthcare, and then some kind of strengths and limitations and how we can apply it in entities. Now, if we're going to start this course, we're going to be asking what's intelligence. Now, to address that, intelligence is just the ability to learn from experience, adapt to new things, and understand some kind of complex ideas. And just think about it like you now want to apply that knowledge to manipulate some kind of circumstance in your environment. Okay, that is what intelligence is all about. Your ability to learn from experience. Okay, so you can be seated down in a classroom, and somebody's talking to you about particular event. And while you're listening to that event, you're picking up some insights that you can now use those insights to apply to some of the things that are happening in the environment where you find yourself. Now we'll talk about human intelligence. What do we mean by that? Human is some sort of action that is driven by cognition, reasoning, emotion, and kind of enables perception, understanding, and what decision making. Now, the question now is, what are some of the key elements of intelligence? When you talk about intelligence, you talk about reasoning, you talk about learning, you talk about problem solving, you talk about perception and adaptation. All these are some of the key elements that culminate what intelligence. Now the question now is, if human beings can now learn and adapt, are you sure machines can actually do the same? That is what we're going to talk about what artificial intelligence means. Now, the definition of artificial intelligence is just like the science and engineering of creating machines capable of performing tasks that normally requires human intelligence. So just think about it as you want to give computers an instruction, and you want them to actually have the ability to imitate some kind of human thinking and behavior, just like teaching a child how to learn, or maybe you want to teach a child how to crawl, or maybe there are quite some couple of things you want a child to learn. Now, that is the same way we teach a computer how to do what it wants to do. Now, the goal of AI, artificial intelligence, remember the word there is artificial intelligence, is to develop systems that can think, learn, and act intelligently. So look at it as Siri. If you use an iPhone, you can actually, ask Siri do this, Siri do that, or ask Siri to get your phone contact, right? Or maybe identify a particular picture or image or object that you're really looking out towards. And the idea is that it understands the language and it works with some of the preferences that it has learned, and it can actually respond intelligently. Other key tasks that AI can perform is speech recognition, image identification. It's also very responsible in decision making, translation, pattern detection, and a lot more. Okay, when you pick up your phone and you want to unlock your phone with your Face ID, that is the task that is performed by what artificial intelligence through what image what recognition. It has the ability to recognize and identify your face, and then it translates to what unlocking your device. Now the question now is, what are the pillars of artificial intelligence? That's what we're going to be looking at now. What are some of the pillars of artificial intelligence? it's quite very imperative for us to know that. Now, one of the pillars of artificial intelligence are it acts like a human being. Okay? Artificial intelligence has the capacity to do what? To act humanly. Okay? Meaning that it kind of performs tasks that human beings has the capacity to perform. And also, it has the ability to think humanly. Okay? So machines usually simulate human thought process, using some of the cognitive models that are embedded into it, which are going to be looking at the later parts of this course. And also, again, is that it acts rationally. Okay, machines sometimes can choose actions that maximize expected performance. All right, and thinking rationally is also another important. It uses logic and evidence to correct some of the conclusions. And another is that what uh, just think about it like, so just think about it as, a self-driving car, right? So what the self-driving car does is that, first of all, it will calculate some of the safest routes in real time using some of the sensor data. Then while it is driving, it is making sure it complies to the what? To the road emotions and all that. So from the action of that particular car, you see that it exhibits what? All the pillars of what? Artificial intelligence. So just understand that artificial intelligence is not just the chatbot. Maybe let's say, for example, you're watching this video in 2025 or 2026, where you're already used to chatbots and all that. Just understand that some of the fundamental pillars of this chatbot is acting humanly, and beyond the chatbot, some sort of the other machines, that you use like phone, Siri, and all that are all using what? The artificial intelligence pillars to act humanly, think humanly, act rationally, and think what? Rationally. Now, as a mode of introduction, I would just want to walk you through some kind of a brief history of artificial intelligence, and we can actually look at artificial intelligence as far back in the 50s, when where Alan Turing introduced the Turing test, where he asked if machines can think, and also in 1956, the term artificial intelligence was coined during a Dartmouth conference. And then also, there were actually evidence of early chatbots in the 60s, by, you will remember the ELIZA chatbot, that tries to simulate conversation. And it goes down to 1997, IBM's Deep Blue, IBM's Deep Blue achievement that kind of defeats the world's chess champion, Gary Kasparov. Now, it also evolved down to 2011, during the jeopardy of natural language processing. 2016, Sophia the robot becomes the first AI humanoid citizen. And then that is where it continues to transform. Now, we can actually look at the milestones in AI chatbots, how OpenAI, Gemini, and other competitors, how they continue to compete, for power in AI, looking for who is going to present more like the AGI, artificial general intelligence, or artificial super intelligence, which is something we don't really know if it's something that will come to fruition. So today, it's now something very powerful that artificial intelligence now currently powers your Google search. If you open your phone while you're watching this, probably you might want to just put in a query on your chat, on maybe your Google board there, and you see that some of the responses you're getting from the Google engine is, some of them are AI powered, suggestions from artificial intelligence. While you're scrolling on Netflix, Netflix could give you some certain recommendations of videos based on some of the previous videos you've watched, or the background information of some of the data you've provided to them. Now, all these things are done as a result of machine learning processes, okay? And what the machine has learned about you and what they feel you would be interested in. Now, another part of AI is disease diagnosis and also autonomous cars, which we previously talked about, driving or being in a self-driving car. So all these mechanisms are powered by what? Artificial intelligence, because what it means is that you are not the one making the decisions, but rather the machine is making the decisions based on what it has learned, the experience it has gotten from previous world's data. Now, while we're also getting grounded with the theories, I would also want to also understand why artificial intelligence is currently on the rise now. And this could be as a result of data explosion. There's already massive data from social media. Data has it that almost every day or per second, almost more than a million, information is being put into what social media, and because of these trends and all these insights, data, from a lot of repositories, this is one of the factors that is driving the growth of AI. Remember that we define intelligence as learning from experience. So what it implies is that while information from various individuals or from various categories or various strata is being plugged into the social media or into other platforms, like the IoT devices or other healthcare streams, you find out that it gives room for artificial intelligence systems to learn patterns from this particular one data. Now, another one factors that is driving the growth of AI, artificial intelligence, is some of the advancements in algorithms with the invention of neural networks, optimization methods, and you see that this is something that is really contributing significantly to the growth of artificial intelligence, the rise because of what neural networks that are quite present and how so many of these models are now being scaled. Okay. Another is what results. Complex tasks like image recognition, speech recognition, or medical image analysis is now a routine. So it means that with what results that we currently have now, it means that artificial intelligence has to grow because a lot of processes currently now in several organizations now has to be what automated, and this is what makes artificial intelligence what a driving factor in growing. Now, another is what improved hardware. Now, with the latest invention of GPUs and cloud computing, enabling faster processing, this has also significantly influenced what the growth of artificial intelligence. Just like global investment, that is made by government. While government continues to fund artificial intelligence initiatives, in turn, it happens to what? To be growing. Now, this is a very fundamental part of discourse, and in this particular section, we're going to be talking about some of the types of artificial intelligence. We're going to be looking at some of the types of artificial intelligence. Now, we have three major types of artificial intelligence. A lot of people are hearing about AI, but I doubt they still get to understand some of the categories of AI. We just have three categories or types. First of all, we have what we call the what? Artificial narrow intelligence, what we call the ANI. Okay, now this is just like look at the artificial narrow intelligence, like maybe you pick up your phone, facial recognition, voice assistance from Siri or Alexa, and most sort of you can look at it as ChatGPT. You put an information on ChatGPT, automatically it returns some desired insights based on the command that you've uh, essentially given to it. And Google Translations, probably a friend in North Korea sent you a message, and obviously you have to translate it to your own local language. Maybe that could be English language or whatever. And all these are what we call artificial narrow intelligence. Okay, so this is just where we currently are standing. You use facial recognition, you use voice assistant, and all these things are what I used to call agreeable AI because this is what you've trained it to do, and of course it has to do it. Okay, when it's translating the language, it has already been trained that this is what this is. When you translate this is what it should give you. It has already been trained that when you before you set your face ID on your phone, you already put your face, right? Get some couple of images, and then when you now anytime you've synchronized or you've already activated the security measures, using your facial identity, then each time you pick up your phone and put it to your face, automatically it unlocks because of what the gadget has now learned, gotten enough information about your face. All these things are what we call artificial narrow intelligence. It's quite very important for me to stress very much on that. Now we have the artificial general intelligence, okay? And now in the artificial general intelligence, now this is where the game changes because a lot of people, a lot of big companies, the competition is fierce towards AGI, artificial general intelligence. That is where everybody's asking who is going to be at the leading race for AGI. And what artificial general intelligence implies is that what machines can actually have some kind of human level of understanding and reasoning. And remember, this is something that has not yet been achieved. Okay, where it is expected to be that automatically machines get to make their own decision, automatically machines get to read the room, they know how to reason, understand without necessarily being fed with what data. As it opposes the what artificial narrow intelligence, where you have to be the one to put your face and all that. So just think about it as tomorrow you see a robot that automatically starts performing functions and all that. Not necessarily has it really been programmed to do that. So for AGI, it has not yet been achieved in this world. And the last one is what we call ASI, artificial super intelligence. Remember, I did talk about artificial narrow intelligence, I talked about artificial general intelligence, and now I'm talking about the last one, which is artificial super intelligence. Now, what does artificial super intelligence imply? It implies that machines now will now surpass human intelligence. Contrary to artificial general intelligence, which has not been achieved, that I talked about it being machines being at the level of human intelligence. In artificial super intelligence now, machines are now going beyond, and it's something that is theoretical right now in science, and it's only present in films, just like robots, where robots can perform more function than what human beings. But the difference between AGI and ASI is that AGI, artificial general intelligence, is that the level of knowledge now from the machines now is equated to what that of humans. And humans can make decisions. I can decide to stop this video right now, maybe due to some certain decisions. But that is what AGI can do, an AGI automated system, that probably might have been designed by itself. Whereas for super, it is now beyond human beings. Okay. Now we're going to look at AI, machine learning, and deep learning, try to differentiate and understand some relationships. Now, artificial intelligence now is just the broad field of making machines intelligence, right? Now, when we talk about artificial intelligence now, this is how it differs from machine learning and deep learning. I'll repeat. Artificial intelligence is the broad field of making machines what? Intelligent. Whereas machine learning is just like a subset of AI that now learns patterns from data that has been given to it instead of being explicitly what? Programmed. So normally in artificial intelligence now, you can look at it as what? Maybe you want to give machines some kind of command, and you want to take a picture with a phone and probably edit it to become another thing. You understand? In that situation now, it is what? You're making the machine what? More intelligent. Now, but when we now talk about machine learning now, is that you take a picture with the phone, automatically, the phone now suggests to you how you should edit the picture. In that situation now, it means that it suggests, or why is it suggesting to you? It suggests to you because it has learned from patterns how you edit what? Picture. So if we have something like a universal set, artificial intelligence is at the central area, then a subset of artificial intelligence is what? Machine learning. Whereas deep learning, which I'm going to define now, is a subset of machine learning, that uses multi-layered neural network to simulate the what? Human brain. So the deep learning now is now much more advanced now because it tries to simulate the human brain by using what we call neural networks, which we're definitely going to explain along the line in this course. Now, I'm just going to leave you with an analogy with respect to the relationship between AI, ML, and DL. Is that for AI, look at it as the whole universe, right? Now, for machine learning, look at it as one of the galaxies in the whole universe. And then for deep learning, look at it as the what? Something like a star in the whole what? System that is inside the what? Galaxy. So if I want to still bring down this analogy, I can look at it as the world. Okay? So AI is the whole world. Machine learning is like a continent. A subset of it is like a continent, maybe let's say Europe. Then deep learning is like a country inside Europe. Okay? So that's it. And remember that deep learning tends to be more advanced because it tries to simulate the brain of your what? Simulate just like a human brain, using some kind of layered neural networks. Now, the question now is, what is machine learning? We've talked about what intelligence means at the earlier section of this course, and we talked about what artificial intelligence means. Now, right now, we want to know what is machine learning properly. So, machine learning enables computers to automatically learn and improve from experience without explicitly programmed. Okay, more like without telling it exactly what it should do, but it can actually learn from patterns and perform some kind of actions. Now, how it works is that you feed the algorithm with data, Then from their data that you fed it with, it will now identify some kind of patterns to now make predictions or decisions. Now, some kind of real life example now I will give again is, think of it as like an email spam filters. Okay, when people continue to send spam emails and all that from thousands of emails, what a machine learning model now will do now is that it will learn the pattern of how a spam email looks like. Maybe you're asking for somebody's credit card and all that, and it has already been flagged that these are usually what spam emails. And at the end of the day, what it will do is that what each time that email is sent, it will just flag it into what the junk folder or the trash folder. Now, a healthcare example is just like predicting malaria infections likelihood from patient symptoms and what lab results. So, how is it going to predict it? How it's going to predict it is that that particular healthcare model is going to be fed with a lot of previous cases of malaria, such that it will now recognize that okay, this is for malaria because of all the insights I've got from what from people that are actually suffering from malaria. Do you understand? So based on those symptoms and based on those probably some previous reported complaints from patients, it will now aggregate it and do what? Maybe each time a new data is entered from the patient, it can now say, okay, this is likely what the patient is suffering from. Now, just look at the machine learning process, and remember, it's quite a very simple step. First of all, it starts with data collection, where data is gathered, both structured and unstructured, usually using CSV files and maybe images. We'll talk about this during some of our practicals. Just like think about it as you want to use Python to simulate a model, you've got to read it as probably CSV or JSON file and all that. Or probably you want to kind of go through some insights around an image to be able to match those images to a particular disease conditions or whatever. So we still need to do what? Collect data as what? Image. So when we're done collecting data as images or as CSV files, CSV means comma separated value. Now, what we'll now do now is what we call what? We'll do a pre-processing and cleaning. Usually, we clean the data to reduce chances of bias in our result. Then we try to handle some of the missing values. If there are missing values, we can now simulate placeholder values in place of them. Or maybe if we're not definitely going to simulate, we can entirely remove it to reduce chances of bias in our study. Now, the next one is what? Feature selection. What do you mean by feature selection is what? We will now have to now identify the particular feature that we want to select. Probably want to match, want to predict risk of a certain disease against another. We can now maybe probably use these columns if the file is in CSV. We might now use a part of the file to predict the other part of it. And that's just it. So it just depends on the context. If it's for images and all that, basically, same thing applies. So the next one now is what? Model training. What do you mean by model training? Each time we are done loading our data sheet for machine learning in any particular system, we train the model. It could be logistic regression, it could be linear regression, it could be maybe decision trees, classifiers, depending on the model that we want to use. There are lots of them. And then we'll train the model. Then after training the model, we'll have to evaluate the model, to check if it has the capacity to, identify some kind of maybe test or identify what we are actually looking towards. More like think of it as, just to test it with unseen data for accuracy, because it's very important for us to have an accurate model. The last one is what? We deploy the model. We deploy it. So we use this model now to make real world predictions. So it could be to want to predict the risk of cancer among women in this generation, for example, or maybe among women in a certain group, or among whatever. I want to predict the ability for a machine to detect a fraudulent ATM card. So it all depends, right? So we'll still evaluate them. We'll now deploy it. And when we are done deploying it or launching that, we'll take the cycle again. So how do we by taking the cycle? We start again from data collection, cleaning / pre-processing, and down to deployment. I'm going to talk about some of the types of machine learning. Remember, we talked about the types of artificial intelligence initially, where we talk about ANI, ASI, and AGI. But in the context of machine learning, we have two types. we've got types rather. We've got what we call the supervised learning, we have the unsupervised learning, and we have the reinforcement learning. Now, it's very, very important for you to understand this particular part because the application of these types is something that is really, really going to be very, very important in in that during the practicals of this particular course. Now, when we talk about supervised learning, what are we really looking at? We're looking at the fact that data is being labeled, then we model the model now learns from some of the known inputs that have actually been provided for that study, and we also it also identifies with some kind of output pairs, and another example there, a clear-cut example there is, let's say for example, we're trying to predict probably diabetes risk. Now, we might want to use some of our inputs as age and weight, and then the output is like what? Maybe does this person have diabetes or not? Okay, whereby we're trying to predict what the risk of what that type 2 diabetes or whatever condition of diabetes. So that's what supervised learning is all about. The data is clearly labeled, and the models learn from the input that has actually been given down to the output pairs. Now, for unsupervised learning, not really so much different from supervised, but one of the key things there is that what the data is usually unlabeled. Some of the models that are actually discovered are quite have some kind of hidden patterns. And an example now is, let's say we want to cluster malaria by region. In that situation, it is clearly unsupervised what model. And now the last one is what we call reinforcement learning. And what do we mean by reinforcement learning? Here, machines are actually learning by trial and error, receiving rewards or penalties. And I think an example here now is just like, think about it as a robot that is trying to learn how to navigate obstacles. Now, contrary to supervised learning, where you already have an output of what you want, what you feel it's going to be, and in unsupervised learning, you don't really have what you've envisaged it to be, but rather you just try to cluster data. For the case of reinforcement, it could be that what maybe a kind of you're in a system that you're trying to learn how to navigate obstacles. Now you don't really know what the output is going to be. In this case, it's what reinforcement learning. So I'm just going to explain, like I said, mostly largely on theories. I'm just going to explain some sort of supervised learning before I jump straight into coding. But you need to understand that supervised learning follows this particular cycle. We predict the outcomes using the labeled out data. Now, one of the common algorithms or models that we use here is what? We use linear regression, we use decision tree, we use support vector machines, and a lot of them. Now, an example now is we're trying to predict the hospital readmission using past patient data. Remember, one of the key things you need to know for supervised learning is that somehow you know what the outcome is going to be. So you're trying to predict the outcome using the kind of data that you've labeled. Now, the key idea now is that you want to learn from examples. It's something that is similar to how human beings learn from past questions or practice questions. Now let's look at unsupervised learning. And for unsupervised learning, the goal is to do what? Find patterns or structure within unlabeled data. So here now, some of the data that is given to the computer or whatever is not really labeled, okay? And then it's now left for it to figure out some kind of patterns within it, contrary to supervised, where it is labeled and we know some kind of outcomes I want to predict. So some of the methods or algorithms here is we use clustering. K means clustering, which is very statistic. We use dimensionality reduction, and that is what? Simple linear regression. Okay. And for the dimensionality reduction, also it's also very important for us to understand, some kind of simplified complex data, using PCA. Now, an example is what? Grouping NTD patients by symptoms or environmental factors. So, on the course of that grouping, patterns will begin to do what? Unfold. Now, let's quickly explain reinforcement learning And reinforcement learning here is just like agents are learning by interacting with what? An environment, and also receiving rewards for what? Correct actions. That's just what the concept is all about. And an example of that is what? Maybe, let's say, for example, you have a diagnostic model that's adjusting, you're trying to adjust it for prediction based on accuracy feedback. In that case, it's more like what? Reinforcement what? Learning, yeah. So one of the famous cases here now is the AlphaGo by DeepMind, where we are actually learning how to play Go better than humans. So in that case, now you see that what? All those agents now actually interacting with one of the environment, and they're receiving a reward for correct what? Action. So think about it. Another is what? Maybe you're trying to predict, not like really predict now, but you're trying to ascertain the accuracy of a particular instruction that was given out. In that situation now, when an instruction is given out now, it might be good or bad, and that is where it kind of receives reward. So personally, a very good commendation always works very better, because once you've got a good commendation, it gives you more effort to work very hard. Now there are some certain people that when they don't get good commendation or good testimonials, when they get a bad one, it might also give them what? But also, so it might also give them more like some kind of that rewards now for that correct action. Okay, so that's it. Now let me use a healthcare analogy now. So just think about reinforcement learning as what? Optimizing what? Treatment. Maybe treatment schedules, or you might want to actually optimize them dynamically. So you use what? Reinforcement what? Learning. So guys, now we're coming to deep learning, right? And in deep learning, like we defined earlier on, we talked about deep learning as what? A subset of machine learning that uses artificial neural networks. Now, are there non-artificial neural networks? Probably yes. And I'm just going to explain that in an example, kind of. Now, remember that as for you to get into deep learning, you need to understand that first of all, it is something that is underneath of what? Machine learning. So it means that you need to be very, 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 very comfortable with what? Mathematics, and also the syntax of what? Python, or any kind of programming language that you're using to automate your machine learning process. So it is also something that is inspired by what? By the human brain. So the way the deep learning works as a subset of machine learning is that what? Look at the layers of the neurons now, of the brains now. So it is what tries to remember the price you and somebody had maybe some time ago, or maybe there was something you did before, or there was a kind of conversation you had and you're able to recall, right? So there are actually some kind of neurons that are that maybe probably they are responsible for that. So it means that when we are trying to train a machine now, right, to learn, there is still a kind of recursor brain that the machine does what? Have. So those are any of them that contains that addresses maybe some kind of neuron hierarchies clearly stemming from what? Deep learning. Another example now is what? In image diagnosis, or in image diagnostics, the lower layers, are ones that dictate some of the edges, right? And middle layers dictate shapes, or higher layers. While the higher layers quite does what? They dictate the full organ or what? Parasite. Remember that deep learning is very, 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 very fundamental for any AI that is currently what? Out there. And you need to, one of the things that makes it powerful is that what? It's one that learns automatically from raw data. It doesn't need any manual feature, or probably an extraction needed. Now we're going to look at deep learning in image recognition. I'm just going to talk about deep learning in image recognition. I'm going to just start with a use case of detecting malaria parasites. Okay, now there are some of the frameworks that we have for deep learning. One of them is what I usually call the CNN. That is the convolutional neural network, and this is one that scans all the small sections. Do you understand? We also have other neural networks, a lot of them that we do use, but the CNN is one that is widely what used. Remember that when we're talking about detecting malaria parasites, a time ago we went for a designer, not just a designer, I think that was a field work where we tried to match images of neglected tropical diseases using deep learning. And what it means is that when you take a picture of somebody that has the manifestation on the leg, right, the function of deep learning now is to, it has that recursive ability to do what? To understand the convolutional neural network, scan all the section of that wound, and return it back to tell you that based on image recognition using deep learning, this is what we call maybe leishmaniasis or ascariasis lumbricots, whatever. Okay, yeah, that's it. Now another one now is what the outcome is faster for deep learning. There is more consistent and cost-effective diagnosis in what, in low risk, in low resource clinics, kind of. Although so for some certain countries, they might be battling with that as well because of this SDG goal for equity in access to healthcare. Now, I'm going to talk about some of the AI in healthcare examples. I'm sure you are very, very excited to get into the very next stage of this course after we look at these examples. One of them is what, disease diagnosis, right? So these are some of the areas where AI, machine learning, and deep learning is being applied, okay? So anytime I use the word AI, I'm also talking about ML and DL. So one of them is what, disease diagnosis, right? So our ability to predict tuberculosis, malaria, schistosomiasis from DCA is something that is done by what? The elements of what? The pillars of artificial intelligence. Another area is what? Drug discovery, okay? Now, AI models suggest promising compounds very faster. So I did read an article that someone said, okay, just actually the person said, use some of these models now to detect like the potentials of a particular drug or a particular whole plant therapy. And if you look at all the models and the way that particular insight has been simulated, it's clearly what, an application of artificial intelligence. Another application then is public health surveillance, and where we predict what, disease outbreaks. Okay, and yeah, recently we've got to predict which surveillance method is quite more scalable compared to traditional ones. And when we looked at some of the ones that were AI assisted, we realized that they are quite very well efficacious and very, very more like articulate to be used. So artificial intelligence plays a very massive role in public health surveillance. And yeah, that's it. Now another one is what, personalized medicine. Okay, AI also plays a role in tailoring treatment plans using predictive what models. That's what we need to understand about personalized what, medicine. And just like I'll reiterate again, some of the key examples, it's just like the Google's AI that helps in detecting diabetic retinopathy. Okay, and these are some kind of diseases that are from retinal scans in India. Now, what are actually some of the strengths of artificial intelligence in healthcare? One of the strengths is what? It reduces human error and diagnostic time. There's a lot of, more like hands are being clapped for AI for how much it is now influencing, it is influencing the risk of what, human error during diagnosis. So this time around now, you don't get to go to the hospital and manually somebody is predicting you to have another ailment. But when the machine gets your complaint, there is actually tendencies for it to bring out bias-free what, judgment of diagnosis. Another particular benefit there now is what, there is now more remote diagnostics, right? It supports decision making in under-resourced areas, and also the fact that it promotes early intervention and disease what, prevention. So basically, AI in healthcare has so more examples more than this, and just understand that it can actually handle large and complete data quickly within split seconds. This is something humans cannot really be able to do. Now the question now is, what are now some of the limitations and ethical issues surrounding artificial intelligence? One of them is what, data quality. I've just actually outlined the sketch of what you need to know, and it's just basically you getting to know that One of the challenges there is what data quality. What there is what biased or incomplete what data. That's what inaccurate predictions. Sometimes AI make mistakes. Interpretability. The black box. What I call the black box problem, where it is hard to understand how decisions are made. So the fact that you put the prompt and it quickly runs it out, you don't even know how it made the decision, and all that. That is what we call interpretability, and it's a concern for artificial intelligence now. Another one is what we call the what privacy concerns. Now there are tendencies for your data to be out there, to be used in several repositories, or to be used by various sources, whereas it wasn't something that you authorized. And that is one of the things that the OpenAI LLMs and other uh, chatbots usually are fond of. Where whenever you uploading any image, it does clarify you that you need to actually agree to the privacy and terms policy that your data is going to be used for literature. More like what I mean literature now is that it's going to be used by others. Okay, and that is something that can actually compromise what privacy. Patient data can be misused. It can actually pose people to a lot of what risk. Another one now is what the cost and infrastructure to set up an AI hub or an AI research lab comes with severe costs. In short, for artificial intelligence to run, you need a lot of computers. You need a lot of computing power, and this is one of the things that one of the chief executive officers of Tesla, uh, Elon Musk, did mention that some of the GPUs that are used in artificial intelligence is quite enormous, and it's something that happens to be a constraint because it poses limitations for individuals that are looking at building AI startups that will be very profitable. Now, another one is what ethical principle. The need and urge to abide by what ethical principles is imperative. That artificial intelligence should assist you, shouldn't replace you, and it shouldn't replace you, both as healthcare professionals. These days, a lot of healthcare professionals are not even doing research. So what it means is that there are tendencies for them to outsource their tasks to artificial intelligence, and then at the end of the day, they are left what empty. Now, looking at this course, to make everything very easy and simple, we're going to be studying it with a direction. And that direction is that we're going to be heading towards neglected tropical diseases. We'll model several entities, screen for some kind of, I'm going to actually check out for some kind of, patterns, do some image recognition using TensorFlow, PyTorch, Keras, and some kind of neural networks. We'll be using it to form a lot of prediction. And yeah, that is what some of the things we're going to be doing. So as of the time when you're watching this course, I currently lead a computational research lab, which is a subgroup of some of our internship laboratories in Sentinel. So yes, one of the things to understand is I'm working on a lot of AI and neglected tropical disease projects, and it's going to be quite of a massive pleasure if you deem it fit to be part of that project. So now it means that what some of the current gap is what there is limited diagnostic labs, late detection, which is such a job. Experts research direction. Okay, it uses low cost smartphone. Research direction there is use low cost smartphone, based image diagnostics. The goal is simple, just to build explainable, deployable systems that can be suitable for what field conditions. Now, for the AI promise, we'll be looking at portable models for speech analysis, oncocytosis, and malaria what detection. So I just really want to thank you for this particular intro of this course, and this is just like a beginning part of this section. A couple of the things we'll be talking about, in the future. We'll go a little more bit deeper into machine learning. We'll also hang ourselves into some kind of mathematical aspects of this, and yeah. So let's take some of our summary key points. And first of all, remember, I do talk about AI as intelligence in machines. That's just what it is. AI is what the intelligence in what machines. And I will talk about machine learning to be what how machines learn from data. Talk about deep learning as machines learning like the brain. Okay, I will talk about machine learning to be classified into supervised, unsupervised, and what reinforcement what's learning. Okay. And then we looked at AI in healthcare. We said that AI is currently transforming disease diagnosis, prediction, and what management. And now one of the key message I'm going to leave you with is that the future of healthcare and infectious disease and neglected tropical disease management lies in merging human empathy with machine intelligence. So just want to really thank you for this series. So our next lecture is going to be on how we can properly implement machine learning for neglected tropical disease. And up next from there, we'll be looking at some of the mathematics for machine learning, and we'll be facing them in real time. So thank you very much for your time in this course. Resources about this for this course is going to be dropped right on our repository. You can visit our site at www.scientism.com, and yeah, definitely going to get everything in it. So thank you and bye bye.